Okay, so in our previous class, we were discussing about the thiophene, benzo-thiophene preparation or synthesis. So one of the method of preparation of benzo-thiophene is about the starting with malic anhydride. This is called malic anhydride, and vinyl. This group is called vinyl thiophene. So what will happen here? So this is a diene and this is a dienophile. So diene and dienophile is required for the Diels-Order reaction. So what is Diels-Order reaction? So the Diels-Order reaction is 4+2 cyclo addition. So this is an example of 4+2 cyclo addition. But okay, right. So 4+2 means 4 electron from the diene side, 2 electron from the dienophile combines. How it will combine? In a concerted manner. Okay, more particularly endo product. Okay, endo product is preferred. How you can identify in this endo product? The endo product means this carbonyl group means bond. This bonds is called bonded pair, and the lone pairs are present on the oxygens are non-bonded or non-bonded. So endo product means there will be interaction between the bonded and non-bonded bonded electrons with the pi bond. Okay, that is the ended. That means this should be inside. And what is outside? What outside should be H. So that means here H should be outside and this group should be inside. And once they inside means they will have an interaction with the bonded pair as well as this bond pair, lone pair as well as this bond pair. Such interactions gives you less energy compound, thereby endo product is more stable. Once this endo product is obtained, so this on heating. So on heating, what will happen? There will be a decarboxylation. And also in addition to the decarboxylation, there is also a decarbonylation. Decarbonylation means removal of CO. Decarbonylation means removal of CO. Decarboxylation means removal of CO2. So once there is a decarbonylation and decarboxylation, there will be a double bond formation here. So afterwards, dehydrogenation. Dehydrogenation means removal of hydrogen. Removal of hydrogen is nothing but a what is called as oxidation. So but here you can write yes, sulfur is there. So maybe I can take the pencil and I can write here. So, but okay, what I will do? Yes. So here sulfur is there. Then afterwards one hydrogen from here. So the bonded pair can come over here. This bond pair can go over here, and this hydrogen will go out. So removal of H2. So thereby leads to the formation of benzo-thiophene. So this is one method of preparation of benzo-thiophene. So let's look into the chemical properties. Okay, I will go for a next page. I will go for a next page. Okay, now it will come. Okay, so electrophilic substitution reaction. Electrophilic substitution reaction is a characteristic property of a aromatic compound. So of course, benzo-thiophene is also a aromatic compound. So here the electrophile is NO2 plus in the case of nitration. That NO2 plus is attached to the third position. So what is the difference between the benzofuran and benzo-thiophene? In benzo-thiophene, electrophilic substitution occurs at the third position. In benzofuran, electrophilic substitution occurs at the second position. That is only the difference. So here nitrating mixture is HNO3 and H2SO4. So HNO2 is responsible for the formation of electrophile called NO2, NO2 plus. NO2 plus is called nitronium ion. So that nitronium ion attacks the third position of benzo-thiophene, and later on there will be a proton elimination and then will be a product formation. So you can also write the mechanism for the conversion of these two. So similarly, bromination. So bromination means here the electrophile is Br plus. How the Br plus is obtained? The first step of the electrophilic substitution of bromination is the generation of electrophile. Br2 undergo heterolytic cleavage forming Br plus and Br minus. Okay, Br plus is the electrophile that is attacked the third position of benzo-thiophene, forming a rhenium ion. That rhenium ion is stabilized by resonance. So later on, proton elimination and then forming a product. So the product name is 3-bromo benzo-thiophene, and here 3-nitro benzo-thiophene. So with this, I will go to the next chemical property. So next chemical property is oxidation. Here the oxidizing agent is hydrogen peroxide. So hydrogen peroxide means here what it will do, it will add a oxygen to the sulfur. If it is adding one oxygen to the sulfur, it's called sulfoxide. If it is adding, if you are taking more quantity of hydrogen peroxide, then it can add 2 oxygen to the sulfur. Then the obtained one is called sulfone, and the name of this compound is called benzo-thiophene sulfone. What it means? So benzo-thiophene on treating with hydrogen peroxide in acetic acid. Here the acetic acid is a solvent. Okay. Then what is the product obtained? So the product obtained is benzo-thiophene sulfone. Benzo-thiophene sulfone is the oxidized product of benzo-thiophene when it is treated with hydrogen peroxide. And here the acetic acid, it's only a solvent. So with this, I will go to the next slide. So one more name is there for this. So what you can say that this is the number 1. So that means 1,1. Okay, 1,1 dioxa. 1,1 dioxa. Thiophene sulfone is the one more name for this benzo-thiophene sulfone. So then with this, I will go to a next slide. So next slide, we are talking about the photochemical reaction. I think you are studied about the photochemistry. So one complete unit. So maybe I think you are aware about the which one is photochemically feasible or favorable, and thermally favorable. Otherwise, what we can say that thermally hallowed, photochemically hallowed. So here, when propylamine is treated with benzo-thiophene. So what it means? So you can take benzo-thiophene in acetone in a conical flask, add propylamine. Okay, just cover with the aluminum foil and keep it in the terrace, so that the flask containing reactant react with the sunlight. So what will happen? There will be a reaction. So what is the reaction? It's an addition reaction. Hydrogen will add to here and the propyl group will add to here. So forming a compound called 3-propylamino. This group is called 3-propylamino. So 2,3. So this is what 2, this is 3. Dihydro. Dihydro means there is no double bond here. So then benzo-thiophene. This is the product obtained, and it's a photochemical product. Okay, that what it means? Benzo-thiophene undergoes photochemical reaction in presence of light with the propylamine, giving rise to 3-propylamino 2,3 dihydro benzo-thiophene is the product. So one more for this also a photochemical reaction. I think this is about the 2+2 addition. So this is not the 4+2 addition, because 2 electrons, 2 pi electron and the 2 pi electron are involved, and the obtained product is a tricyclic compound. This is a bicyclic and this is a tricyclic, and Yeah, maybe you can also look into the stereochemistry, what you can get according to the 2+2 addition and photochemically allowed one. So that's what you need to do it. Then benzo-thiophene reacts with, so what is the name of this compound? So if you want to name this compound, you know that without this is methyl group, this also methyl, this also methyl. Okay, and without double bond, okay, it's called malic acid. Okay, so can we call it as a dihydro, okay, dimethyl maleate, okay, is the one compound. So this, when it is treated with benzo-thiophene, it undergoes 2+2 addition in presence of light, so giving rise to a tricyclic compound. So maybe, of course, I think you are aware that the stereochemistry of the reactant is retained in the product. So that is about the stereochemistry. I think this is a okay. So now we cannot say about the cis or trans here, and here we can say that these are cis only. So then I will go to the next slide. So next we are talking about the benzoimidazole. What it means? A imidazole group. Imidazole group means 5-membered ring. Okay, 5-membered ring with 2 nitrogens at 1 and 3 position is called imidazole. Suppose in a 5-membered ring with 2 nitrogens are 1 and 2 position, it's called pyrazole. So that is the difference. So pyrazole means 5-membered ring with the nitrogens are at 1 and 2 position. Imidazole means 5-membered ring with nitrogen at 1 and 3 position. Suppose imidazole is fused with the benzene, then it's called benzimidazole. Of course, this has a wide application in drug industry as well as dye industry. More particularly, this will be an analog of imidazole. Then benzimidazole is more important than imidazole as a farmer occur in vitamin B12. That means this is a one of the maybe what we can say that vitamin B12 is the derivative of benzimidazole. That we can say that. That is the reason it's important. So then synthetic methods. Synthetic method means what are the methods available for the preparation or synthesis or production or manufacture. So then what we know that name of this compound, this part is benzene, and this is 1 position, this is 2 position. What it means? 1,2 diaminobenzene. So what is the another name for this moiety? You know that as per the trivial nomenclature, this position is called ortho. Then what we can say that instead of 1,2, 1,2 is the IUPAC name. If there is a O here, O means what you italic O. So that indicates that ortho amino, ortho diamino benzene, ortho diamino benzene, otherwise ortho amino aniline. Okay, these are the names we can give. So IUPAC name is 1,2-diaminobenzene. So this 1,2-diaminobenzene, when it is treated with carboxylic acid, or maybe a hydrogen, then formic acid. If R is equal to aryl group or alkyl group, whatever it is, it will react with carboxylic. How it will react? There will be a removal of water. So OH and then H, removal of water. What it means? It means that there is a bond formation between this nitrogen as well as this CO. What is the product you will get? You will get an amide. So later on, that amide CO is react with this. That means O and H2. So there will be a formation of new carbon nitrogen double bond. So that's what the product is obtained. Here, it's only the removal of water. I think you are aware about that. If there is a elimination, small molecules like water, HCl, HBr, then we can say that it's a condensation. reaction. Of course, this is also a condensation reaction. So what it means, what we can take from this, 1,2-diaminobenzene on reaction with carboxylic acid, it gives benzimidazole. Okay. So with this, maybe I will go to the next slide. So I will take the next slide. Okay, now it will come. Right. So here I'm taking, you need to remember that if there is a functional group such as C double bond N NH2 is called amidine functional group. Okay, so this C double bond N NH2, this group is called amidine group, and this is a phenyl group. Phenyl means it belongs to aryl, and this is a bromine. Of course, bromine belongs to halo. So in generally, what we can say that N halo. This is the N halo amidines. Amidines means this type of functional group containing compounds are called amidines. So N-haloamidines on reaction with sodium methoxide. How you will get sodium methoxide? Just dissolve the sodium metal in ethanol, you will get a sodium ethoxide. Okay, so then what is its role? Its role is captures this Br. So leaving behind the bonded pair there. So okay, overall this sodium methoxide is a strong base. It captures this proton, leaving the bond pair there itself. So once there is a leaving the bond pair there, then what will happen? There will be a nitrene formation. So this N2 electron in addition to the lone pair is called nitrene. So nitrene is a highly reactive intermediate. Via nitrene, the product is formed. So what is the product? The product is 2 substituted imidazole, benzimidazole. So here sodium methoxide takes out this Br plus, leaving behind the bonded pair there. Then of course it will also this also it will go out. HBr will go out here. How HBr? Maybe how I can say that NaBr is one of the living group. Ethanol will be the one of the living group, forming a nitrene. Nitrene means there will be a 2 electron in it in addition to the lone pair. So that is called nitrene. Since it is a electron deficient one, this bond pair will attack here. So there will be a new bond formation between this nitrogen and this carbon. So that's what I have written here. Still there is a what is called 2 electron on nitrogen. This 2 electron on nitrogen captures this proton. Why it is capturing this proton? Because this bonded pair are moving over here to regenerate the aromaticity. So this is the mechanism part and this is the reaction part. So what we can say that? We can say that N-halo. Okay, this is the N, this is the halo. N-halo amidine derivatives on reaction with base. The base may be sodium methoxide or potassium methoxide, propoxide, methoxide, or tertiary butoxide. So whatever it is, here you should look into that only the base. And the product is this. And this product is formed via nitrene intermediate. So nitrene intermediate means there will be a 2 electron in addition to the lone pair. That is the nitrate. So this reacts, giving rise to benzimidazole. So with this, I will go to the next slide. So next slide, reactions, more particularly chemical reactions. Up to this, we discussed about the synthesis or preparation or production or manufacture of benzimidazole. So now we are discussing about the properties, chemical properties. So, okay, if we are looking into the chemical properties, this I think since it contains two nitrogens, 2 pKa units weaker as a base, but somewhat stronger as an acid than imidazole. Okay, so that may that's what you need to remember. The bicyclic systems are weaker bases than corresponding monocyclic heterocycle. So what it means? It means that imidazole is more stronger base compared to the benzimidazole. That's what you need to remember. So here chemical reaction means I think you are aware that electrophilic substitution reaction. So and one more thing you need to remember, here there is a labile proton. Nitrogen is having a labile proton. Why it is labile? Because nitrogen is electron negative in nature. So it always tends to occupy anion on it. So that is the reason this proton is labile. And one more reason is there will be a movement of this NH proton from one nitrogen to third nitrogen. So that is also it's called tautomeric form. So because of tautomerism, this nitrogen is labile. So labile means easily one can abstract the proton. So what it means? It means that there will be a new bond formation between this nitrogen and a electrophile. So here, what is electrophile we are taking? So we are taking acetic anhydride we are taking. So here I am taking R. So if we are taking a methyl, it's called acetic anhydride. If we are taking a phenyl, then it's called phenyl acetic anhydride. If we are taking some other one, that anhydride will be the product. Then it only acts as a source of acetyl, means electrophile. It will act as a source of electrophile. The anion, what we can say that the bonded pair or lone pair can attack electron deficient carbon, forming a N-acyl. This group is called N-acyl benzimidazole. Is the one chemical reaction example of benzimidazole. So what it means? It means that NH proton is more labile. It immediately reacts with electrophile. The electrophile may be a carbon electrophile or okay, carbon electrophile means we can say that alkyl halide, aryl halide, acyl halide, whatever it is. Okay, methyl bromide, ethyl bromide, many things. Forming a N-alkylated or N-acylated products. So with this, I will go to the next. We can also say that this is N-acylation. We'll go for next chemical reaction. So next chemical reaction is electrophilic substitution reaction. I think you know that NBS, I think you are aware about the NBS. NBS is N-bromosuccinamide. It will act as a source of Br plus. And you know that NBS is a what you call allylic bromination. Of course, what will happen? This position, since this position is active towards the electrophilic substitution, so Br will add to this second position and forming a product. Maybe you can also write the mechanism for conversion of benzimidazole to 2-bromo-benzimidazole. Okay. Then nucleophilic substitution reaction. This is an example of electrophilic. And here I'm taking only NBS. You can also take any electrophilic substitution like nitration, sulfonation. Okay, but why I am not taking? I think you are aware that this is a benzene ring. Benzene ring also tends to undergo electrophilic substitution reaction. Okay, so that is the reason I'm taking only the NBS. This is selectively attack at the second position. So then I will go for the nucleophilic substitution reaction. So suppose if there is a living group is present on the second position, so this can be replaced with the nuclear. Okay. Right. So it will go to first one. 1 minute. I will go for right. Okay. Right. Right. So we were okay here. This is called thiourea. Thiourea can replace the chlorine, and what is adding? Adding will be the SH. So chloro will be replaced with the SH. So SH is called mercaptol. Okay. So that's what the nucleophilic substitution reaction of benzimidazole. So with this, I will go to the next slide. So next means we are taking benzoxazole. What is oxazole? Oxazole means a 5-membered ring with oxygen and nitrogen at 1 and 3 position is called oxazole. Suppose oxygen and nitrogen are at 1 and 2 position, then it's called isoxazole. So in a 5-membered ring, if the oxygen and nitrogen are at 1 and 2 position, then such compounds are called isoxazole. In a 5-membered ring, if the oxygen and nitrogen are at 1 and 3 position, is called oxazole. Suppose oxazole is fused with the benzene, it's called benzoxazole. Right. Okay. So let's look into the synthetic methods or preparation or synthesis or manufacture or production. This benzoxazole, it is possible to synthesize or prepare or manufacture starting with the aminophenol. So this is called amino. So here the parent compound is phenol, amino is the substituent. So what we can say that orthoaminophenol, otherwise 2-aminophenol. 2-aminophenol when it is treated with acid halide. Okay, acid halide means here formyl halide, because only one carbon is there, that is the reason formyl halide. Halide may be a chlorine, bromine, or whatever it is. This reaction requires the catalysis of boric acid. What is boric acid? H3BO3 is the boric acid. So then what will happen? There will be a new bond formation between the nitrogen and this carbon. And what is living group? HCl will be the living group. Then what is the name of this compound? So you know that this is the nitrogen, and this group is called formyl. N-formyl. N-formyl. N-formyl aminophenol. N-formyl aminophenol is the name of this compound. So this on heating, okay, just by heating, so there will be a removal of water. So you know that the lone pair or the bond pair will attack here. Okay. So what it means? It means that this H, and this O will go out, and there will be a forming a new bond, new single bond between this oxygen and this carbon, and there is a double bond here. So the obtained one is benzoxazole. So what it means? Benzoxazole can be obtained by treating aminophenol with the formic acid in presence of boric acid, which leads to the formation of N-formyl aminophenol. The obtained N-formyl aminophenol on heating gives benzoxazole. So one more method. So equivalent, instead of taking the acid halide, so one can take orthoformates. Name of this compounds is called orthoformate. So more particularly ethyl orthoformate. Okay, how you will get this? So I think you are aware that what is called formic acid. So take the formic acid, treat with ethanol. Okay, you will get orthoformate. So orthoformate is a liquid. Of course, this is also a liquid, but when you are handling wise, so this is quite easy compared to this one. Here there will be a liberation of HCl. HCl is a gas. So you need to the liberated HCl, you need to pass it into a aqueous solution. Then only it's fine. If you are not passing, it will harm health. Whereas here, what is the living group is ethanol. Ethanol is a liquid. So no, it doesn't harm like this. So of course, this is hazardous, whereas this is not an hazardous. Because nowadays people are using it as a hand sanitization. Of course, isopropanol is the one they are using it nearly 60% one. Ethanol is costly. Isopropanol is cheap compared to this one. So overall, this is what you call handling wise, more safety is here, but here little less safety is there. This is a hazardous reaction. So that is the reason new method arises. And the new method is treating of aminophenol with the orthoformate. So here the ethanol is the living group. Then there will be a new bond formation with the oxygen and carbon, and the double bond formation between the nitrogen and carbon, forming a benzoxazole. So these are the two methods of preparation of benzoxazole. Starting with here the reactant, one of the reactant is same, but other reactants are different. In one reaction, acid chloride is used. In another one, orthoformate is used. So this is about the preparation. So with this, I will go for a next slide. So next slide is about the reactions, more particularly chemical reactions. And here I am taking the nucleophilic substitution reaction. I think you are aware about the nucleophilic substitution reaction, SN1 reaction, SN2 reaction. So what is of our importance? I think this is the chloro